welcome to my presentation, to my review on problem number 10, Faraday heaping. I'm Lawrence Eberhard from team. So first, you report you had a qualitative explanation. You explained the forming of the heaps with the merging of the heap, and you also mentioned the granular convection, which are three very important points, I think, here. So you did a lot of experiments, but some graphs. In some graphs, they were missing some points, which the opponent also mentioned. So you have the visualization of the convection, which you showed us. You have the acceleration measurements. You have measurements with the varying air pressure, and you have also varied the grain size. And at last, you had, of course, a very good theoretical model, which could also all explain. So I very appreciate this. Then you had some graphs where we just don't know what they mean. There were some units missing and so on. And a big point, you used sand here, and sand is definitely not a sphere as the task says. So I think this is a bit not a task. So then you had no proof of the sign. We say we saw a curve, but we don't know if what it was the voltage or what it was. As I said, mathematically it's not possible. Then you had some variables which you did not define in your report, and you had some missing parameters, which I will explain later. Then to the opposition, we had a very good opposition. You did talk about the errors and some critical values of the parameters, and you also talked about the theoretical model. But also you mentioned the missing friction between the particles, which I think is a very important parameter. Then the simplification, I think, is not justified, which you mentioned, and there were some missing parameters as the type of the grain, so the density, the form of the container, and the number of layers of the grains. Then you used did not mention that he used sand as a sphere. He showed us pictures, and this were definitely not spheres. Then you didn't mention the starting conditions. If there was some dependence of the heap on the starting conditions, and you didn't mention some rotation of the grains which could occur. To the discussion, we heard a very productive discussion. We have the qualitative explanation, which was discussed with the air pressure, and we have also a very long discussion of the increasing of the angle, and we had a final discussion about the theoretical approach. But as you see, these are very few points which are discussed, so we can conclude that some of the points were too long discussed. So my overall impression of the whole discussion and report was that you had a very good mathematical model which could very good explain the phenomenon, but you have missed some parameters in your experiments, and but the discussion clarifies the mathematical model and also the phenomenon, and so we can conclude you had the task fulfilled, which I really found very good. So thank you for your attention.
First of all, thank you opponents for their nicely done discussion, and thank you reviewers for the nicely done review. And I may point some of the points the reviewer or the opponent has had. Let me first discuss about the friction due to the walls. You may see some. Since my slide is not ready yet, I'll talk about friction between the grains really first. First of all, I actually have considered the friction between grains when I said about the electrostatic force, because the electrostatic force was actually induced by such kind of the friction in between the walls. So that I guess I have already mentioned about it. And about this equation, I thought it was a little bit irrelevant to our problem, to my explanation of the problem, because this talks about a microscopic view of a little sand, which also consists of an mg, which is the gravitational term. But what I wanted to express is the macroscopic term, which I try to explain by the full inclination of the hip, and therefore I believe that it was a little bit irrelevant to the problem. And it's ready. And briefly talking about the the 41. This slide, I have actually managed to vary the friction due to the walls using acrylic paper, cardboard, and sandpaper. Next. And as you can see, even the friction changes, the hip angle did not change. As you can see, the air was meant overlap each other so that I can actually conclude that hip angle did not change really much. However, what changed was the convection velocity, which I could explain by the displacement per each cycle of the sand, and only the change by the friction was the convection velocity, which was the displacement per cycle. So concluding my presentation, thanks really much for the jury, the opponents, and the reviewers. Thank you.
Please stay attached. Please stay attached with the copy of the photograph. Okay. Questions from the jury? Please.
How important is the collision with the particles of the sun?
I thought the collision between the particles was important when I have actually measured, I have actually experimented in vacuum in order to measure the critical point of pressure.
And how about the density of the sand?
How about the
density? How compact of the sand?
Actually, the density of the sand I could not measure, but since when I just put the same diameter of the sand into a container, the density is then controlled automatically. So.
Okay. Mark?
The graph with the amplitude versus the frequency.
Yep.
Could you improve that diagram in some way in view of what your theory would say to you? I mean, I would plot that as amplitude versus 1 over frequency squared, actually, because then you get a straight line. This is what you expect, actually.
Yeah. First of all, to explain very briefly about this line was derived into frequency amplitude scale because this equation itself, as you can see from the equation, is an equation of a frequency square equals the gravitational acceleration of 9.8 meter per square second. So I thought it was really easy to look in such kind of scale, frequency and amplitude scale.
Okay, maybe I will ask now once the plot is there again about this point, because looking on this graph,
yeah.
It seems that really this theory is pretty off. Like one would expect something like either straight line or something very, very close to straight line somewhere here.
I agree to your point, and I actually have really tried hard to actually explain such kind of points. And the only explanation I could make was due to the collision between the sand particles and the plate on the downwards. Since due to the vibration of particles, some kind of errors could be made so that it can just put the sand into air so that the air flux can happen. So maybe such kind of discrepancies could be explained due to the collisions.
Further questions? Okay. One question is yes.
Is any theory of dynamic of the motion of the sand? You just use steady state.
I only derived the equation for the steady state because the movement of the sand was too irregular. For example, I have actually mentioned the initial dependence of the sand layers. So therefore, since the sand cannot be exactly flat, and there can be a little bit turbulences and a little bit irregulars, it can depend really much. So therefore, I cannot actually find a model to explain such kind of all irregular cases of the sand model.
Thank you.
One question, the vacuum experiment was very nice. If you have the vacuum cylinder in this, did you consider the number of resting air molecules inside this? What would you believe it is? 1 million or more, 1 billion numbers of air molecules, but the vacuum is not so deep.
So how much air stayed inside of your vacuum chamber?
You
The
remember
number of
the movie?
Molecules.
In the number of molecules.
The number of molecules?
Approximation.
Actually, I guess the calculation could be made, but I actually assumed vacuum has 100 millitorns, and I guess the air molecules, number of molecules could be calculated too using some other
So
equation.
1 million, okay.
Oh,
So
the problem
1
is
million.
I think you can
I have a question from William. What's the first term of your equation?
Yeah, on the left side.
So it's
Hence the
x
so
first-
this constant of the shaker when you push it or pull it, which
Like a string measure?
acts
I
back
like this.
to the
Yeah, I think
level
it's
of
a
the
kind of string measure.
Yeah.
Okay, I have also one question. Like you mentioned your theory with frequency cubed and amplitude squared.
Yeah.
There was a little line down which was called a phenomenological model of the sand. So my question is whether this model comes from the fact that one sees the dependencies and guess it could be third, second power or so on, or whether there is a deep physical understanding why it should be a second power of amplitude and third power of frequency.
Can you clarify your question?
With your theoretical model,
Yep.
it was taken from a paper which was called a phenomenological model of I don't know what. My question is whether the fact that it's frequency cubed has some physical explanation, or it's just that we measure data and we see that it's frequency cubed and write it down. Very short answer.
I believe that it can be connected to the qualitative explanation and the quantitative explanation.
You don't have this connection.
I have the connection since I had actually got the model from my explanation, my qualitative explanation, as I mentioned, from the heaping process. And from that, I got two major things: the surface relaxation and height expansion, and I actually derived the equation from.
We